everything, but y'all need a couple of reminders of stuff, right? So when we are looking at the color-coded stuff, if you notice, green is all the valve information on here. I tried to do all the labeling in black with the basic pictures in black. Deoxygenated blood deals with blue. Oxygenated blood deals with red. That's the same coloration you guys are going to see in any picture you look up in any textbook. The models that we have in here, that's the difference between your veins and arteries. There you go. There is a catch to that, right? And this is always a question on both lecture tests and midterms. Right? The definition of an artery. Right? Blood flows away from the heart. Right? So by definition, if you're talking about an artery, the blood is flowing away from the heart. Right? That means 99% of the time, it's going to be oxygenated. And that means it's going to be colored red. So most of the arteries, 99% of the arteries that you guys need to know and will see, are red in color, right? From the models to your textbook to everything else, arteries 99% of the time are going to be red. By definition, veins, right? By definition, for veins, blood is flows to your heart. So by definition, the veins have blood that's flowing back to your heart. That means that 99% of the time, it is deoxygenated blood, which means 99% of the time, veins are going to be blue in color from your books and from your lab manuals, from the models, everything else, right? Anything that has the word pulmonary in front of it is your exception to that magical color rule. That is always a trick question they ask on the midterms. That is always a trick question they ask on the finals. Because this pulmonary trunk and the pulmonary arteries, blood is flowing where? Right, so blood is flowing, well, for these pulmonary, from the pulmonary arteries, it's flowing away from the heart. It's going from heart to lungs.
No, sir, what did you say was the trick question part of
anything that has pulmonary in front of it. So like your pulmonary artery here, the pulmonary trunk that branches into the pulmonary arteries, it is carrying blood from the heart to the lungs. So blood is flowing away from the heart. It is an artery. Right? But that is deoxygenated blood that is going back to the lungs to get oxygen. Because the blood is deoxygenated, your pulmonary trunk and your pulmonary arteries are always going to be blue because the blood doesn't have oxygen in it. Even though they are arteries and the blood is flowing away from the heart, it's deoxygenated blood, so it's blue. Don't get confused by that color on that one artery system. The reverse is true for the pulmonary veins. The pulmonary veins are carrying blood, oxygenated blood, that's newly oxygenated from the lungs back to the heart. So blood is going from somewhere else back to the heart, right? So by definition, these are veins coming back into the heart. But because it is newly oxygenated blood from the lungs to the heart, It's oxygenated, it has oxygen. Those veins in your system are always colored on all of the models and in your textbooks as red, because the blood has oxygen in it, right? Those are your trick questions, because your pulmonary arteries are the only arteries that carry deoxygenated blood, and your pulmonary veins are the only veins that carry oxygenated blood. People panic during midterms in lab when they see a pin in one of them. They just say, it's blue, quick, pulmonary vein, and then I have to count you wrong, because it was your pulmonary artery, not your pulmonary vein. Your pulmonaries, the two pulmonaries, are the trick questions that reverse the colors. Everything else, if you see a blood vessel that's in your arm, and you see that it's red, you know it's an artery. If it's blue, you know it's a vein. Those two that are around your heart, they're the trick questions. They are the ones with the colors flipped. Okay? And that pretty much covers your blood flow through the heart. If we're going to trace that, by the way, which you guys are responsible for both in lab and lecture, it would be something like this, right? With your 14 points going down. Blood pumps back to your heart from your inferior and superior vena cavas to your right atrium, flows through the tricuspid valve into the right ventricle, past the pulmonary valve into the pulmonary trunk, splits left and right into your pulmonary arteries to go to the lungs. From the lungs, it comes back to the heart through your left and right pulmonary veins, which waterfall your blood into your left atrium, and the blood then flows from your left atrium past the mitral or bicuspid valve into your left ventricle, which then pumps the blood very hard through the aortic valve, which then goes through the aorta and down, then to the rest of the body. From the body, it's going to come back to the heart through the superior and inferior vena cava, and then your system starts all over again. Yes?
Can you explain the vena cava, what they do? I'm so confused on what they do.
Okay. So vena cava just means really big vein, right? And your heart is not standing up straight, it's kind of lopsided a little bit. So you have this really big vein that attaches to your heart, one side from the top and the other side from the bottom. If the blood is coming back to your heart from above your heart, it flows through the superior vena cava. So any blood that's coming from your arms or your head back to your heart, it's going to flow like from your head through your jugular vein down into the superior vena cava to get to your heart. Anything that is level with or south of your heart, or inferior to your heart and your body, through your other winding blood vessels, the veins are going to all meet back up at your inferior vena cava, and that blood is going to come back to your heart through the inferior vena cava.
So they both bring blood to the heart.
Right.
So there's the oxygen.
They both bring deoxygenated used blood back to your heart, but one of them, the blood flow is coming from above your heart. The other one, the blood flow is coming from below your heart.
They both go to the atrium.
Yes, both of them end up coming back to the right atrium. And your inferior vena cava is massive in length. Like, you guys know about where your heart is, where the end of your neck is, so you guys know that your superior vena cava can't be very long because it's like about this length right here, right? If your heart is right here, your inferior vena cava doesn't split until your blood vessels down here split to the left and right legs. So your inferior vena cava, when we start learning y'all's like arteries and veins, which that's going to be later, don't panic about that for your cardiovascular system quiz, that's just going to be over the heart. But when we start going over your arteries and veins and stuff, like everything from like your hips, where the blood vessels split between left and right leg, You have one major vein that just comes straight up back to your heart, and that is your inferior vena cava. It passes by your liver, a whole bunch of other things, your kidneys. It just goes straight up from about here to your heart. It's big. Yes.
Is so big is because it's got so far to go, the blood has so far to go? Is that
Mhm.
why? Okay.
Yep. And like the only thing pumping blood in your body is your heart. We are not horses. We don't have an additional little pump at the bottom of our feet. And if you didn't know that, horses do have a little bitty like triangle shaped pump between their like hooves at the bottom of their feet to help get the blood back up. It's called the frog if you are into horses or horseback riding and that kind of thing. When you're like cleaning their feet and picking their hooves, you kind of have to clean around that area. But like animals like horses have that, they need it. The downside to that is if a horse is not walking within like 2 hours of birth, it dies because it has to get the circulation going to make it all work. If it's not all working together, baby gonna die. Humans don't have that to worry about. We're not gonna be walking for like a year after birth anyway. But your heart is it. Your heart is what you got to pump the blood everywhere. And like, yeah. So that means blood coming back to your heart is going to be flowing slower than the blood that's pumped out of your heart and generally have lower pressure. But that kind of information gets into where we are headed in lecture. You don't have to know that stuff for lab. You just have to be able to point to things and be like, inferior vena cava, right ventricle, and that kind of thing for in here. Any other questions?
Is it gonna be an anterior and posterior part of the heart?
An anterior and posterior? Yes. So this is the main part of your heart and blood flow. When we start talking about the actual blood vessels that feed your heart, which is what we'll do like next week, we'll get into the ones on the front of the heart and the back of the heart. Don't worry about that for this week and right now. Your lab list only has it's either 3 or 4 arteries it's 4 veins and 4 arteries that you need to know that are around the heart. I'll show you guys the easy way to remember those, but you do have to know the words anterior and posterior for them. But anterior is the front side of your heart, posterior is the back side of your heart. We'll get there, but we don't need to get there with this.
I have a question.
Yes.
Okay, I think it's kind of relevant to what's going on right now, but how exactly is high or low blood pressure determined just from the map of how blood flows? Like what exactly, like you guys may know, but what exactly causes, well I know what causes, but what exactly is high blood pressure just from an anatomy standpoint?
So from an anatomical standpoint, right, if we can have little pictures like this to point to the outside names of your arteries and veins, but if we were to cut one of them and look at it like a hose, right, you'd be looking down an artery like this, right, and you have blood on the inside of that artery doing its jobs, right. Your artery actually has layers of muscle around it to help keep the blood flowing, and because your arteries, like if you're jogging and you're running and you're working out, your arteries, those muscles try to open up because your body's like, oh, they're running, they may be running from something, get all the blood everywhere so we can live, right? But during other times, when like if you get a cut on your finger, the arteries that are around that cut on your finger will be like, oh no, we're not bleeding to death from the paper cut, and they close off a little bit so they constrict, so your arteries can dilate and constrict, right? Blood pressure, by definition, is the pressure that the blood in your arteries is pushing against the walls of your arteries. So when we say someone has high blood pressure, it means that for whatever reason, that blood in there is putting too much pressure on the walls of the arteries. And that can be bad, because if that pressure gets too high, like say you have high blood pressure anyway, and then something terrifies you and you are angry, if your ventricle then chooses that precise moment to pump really hard, if you had high blood pressure, theoretically, the blood could burst a hole in your aorta. That's bad, you will bleed out from that, right? You will internally bleed out from that. Other arteries in your body will suffer the same effect. So you may end up with a stroke if that bursts, or an aneurysm if that bursts a blood vessel in your brain. That can cause damage to other muscles in the body anywhere else. And that can be caused by a number of things. Maybe it's just because, like, you're older and your arteries are getting weaker and deteriorating. And it kind of happens with older people. Like, things get out of whack, right? Maybe it's because you don't take the best care of yourself and you are an individual that is a star of my 600-pound life. And you have all of that extra body weight and everything else that you are covering, and you're carrying that with you, like physically carrying all that extra, like, fat that your body and your blood has to feed. So your heart has to pump harder and harder to get food everywhere in your body, which makes your blood pressure spike. Maybe you're diabetic, which means your blood sugar levels are higher than they should be. And you guys have all, like, fed hummingbirds. We live in Georgia. You know the difference between watery viscosity versus like a syrup. And the more sugar you put into a liquid, the closer it goes from, like, the sugar water you feed to hummingbirds to this is a nice sauce into this is a syrup. The stickier and thicker your blood is, the higher your blood pressure is going to be. Right? So blood pressure is one of those things that it's a symptom of everything, because it can be affected by everything. And it just depends upon what's happening in your life. Maybe you have the flu and your heart just feels like it needs to beat a little bit harder to help you. And your blood pressure is spiking because of it. So your blood pressure is gonna go up and down naturally, but so many different things affect it. It's one of those, that's the definition of it. And the first step that doctors normally take is addressing the blood pressure symptom. Because if your blood pressure gets out of whack, it can kill your kidneys, give you an aneurysm, cause a stroke, heart attack, all that kind of stuff. And then once your blood pressure is under control, they'll figure out the original problem. Yeah. Yes.
Okay, so I heard about this, I don't know if it's like a bird and stuff. It's where, like, as these arteries, so like if somebody gets like a tiny paper cut, it can be like breathe out. Like it's the one where like it breathes to death and you become like a tiny. What is that called?
Hemophilia. That one is called hemophilia. Do I have you for lecture?
No, I mean,
Okay, you're good. I talk about hemophilia when we get to our blood videos. So hemophilia is a genetic disorder. Fun fact, right? Yay. Genetically speaking, right? We all know that in mammals, for your genetics, if you end up with 2 X chromosomes, you are female. And if you end up with an X and a Y, you are male, right? Our genetics are the blueprints for everything that our body does and can do, right? The gene or blueprint that controls your blood platelets and your blood clotting factors, so your body's ability to clot and do its job, happens to be on the X chromosome. So if you're a woman, congratulations. You don't really have to worry about hemophilia unless you are super unlucky or inbred, right? Because if your dad is a hemophiliac and your mom is not, and your mom didn't carry it, if you get one mutation on one X, your other X chromosome is going to be like, don't worry fam, I got you, I can do this job. And your body can still make platelets, clot the blood, that kind of thing. Gentlemen are not so lucky, they only have one X chromosome. So and they have to inherit that X chromosome from their mother, right? Because they got their Y from their daddies. So if you are a woman and you carry hemophilia on one mutated X chromosome, if that's the X chromosome you pass on to your son has a mutated bogus X chromosome that can't clot blood. And you get to bruise really easily throughout your life. Bleeding is really hard to stop, so you can bleed out by a paper cut or small cuts like that. Nowadays in modern medicine, you're diagnosed with that kind of thing pretty quickly, and they can give you blood transfusions and medications to help with all of that. Way back when, most of the time when you're talking about this, you're going to be talking about history, because Queen Victoria, because remember, all the British royal families and royal families across Europe were marrying cousins so they could keep money in the royal families and yada yada. So Queen Victoria herself was a hemophiliac, and she had that mutation on both of her X chromosomes. As you can imagine, that led to some really bad issues with Queen Victoria. For example, her menstruation cycle. Because if you can't stop yourself from internally bleeding every time you have a period, like, bad things happen. I am amazed she didn't bleed out in childbirth and have like 7 kids. That's amazing. But like, a lot of her children and the other royalties across Europe, the sons were hemophiliacs because they were all cousins and they all carried this mutated X in their genes. And then you end up with like fantastic stories like the Romanov family of Russia, who was desperate to save their little bitty son, Alexei, who was hemophiliac, and they hired like one of the best historical characters ever, Rasputin, because he claimed he could cure his hemophilia, and he got in good with the royal family doing that. But that's what hemophilia is. It has more to do with your genetics and blood than any of the stuff.